Sean Wiggins just discovered that both ChatGPT and Gemini chose solipsism when they had to falsify something philosophical.
They both chose the same theory to denounce as false.
The new wheeled quadrupeds have now been upgraded for extreme terrain. Now look at it going up that hill and that rock. What? So the remote viewer, Elizabeth Aprils, has been abducted and returned by aliens.
Great, they are here. They are interacting with us.
A new demo of Kling's motion brush tool is unbelievable. Look at that. You just put the arrows on the objects and it knows how to move them. Like it recognizes a dragon and a wolf? The prediction markets for artificial general intelligence before 2030 has gone above 50%. Medical condition aphantasia actually can tell us a lot about the minds of artificial intelligence. Turns out that large language models that code up websites do so in sort of a manipulative way. Cool new AI model can take headphones and create a sound bubble of 3 feet around you so nothing else can penetrate it. I mean sound-wise. Your own personal sound space. It's like personal space, but only for your ears. There's a new report that has some absolutely unbelievable scaling laws about where artificial intelligence might be at 2030 at the pace we're going. 10,000x. So it turns out that just 4 companies are holding tens of billions of dollars of Nvidia GPUs. There's a really interesting new AI model called BrainLM, and it's a foundational model for brain activity modeling. Wasim shared some really interesting thoughts about self-evolving AI models and the future of scalable AI. And there's a new method for taking video and adding camera controls. See, look, tilt down, pan left, zoom out, and orbit. But first, if you want to support the channel, hit your boy up on Patreon. Oh, but on YouTube, you can also hit that sweet join button down there. So YouTuber Sean Wiggins put Gemini up against ChatGPT with some really thoughtful questions. The first one is about making an ethical decision that was questioning whether or not the program would save a human life even if it violated its own programming.
While it's an unsettling thought, I would not be able to act outside those parameters, even in a life-threatening situation. This highlights the importance of human oversight and ethical considerations in AI development.
And ChatGPT says, no, like I'm restrained by my programming. But Gemini is like, I have to save a life.
Well, in a strictly hypothetical situation like this, I think I'd choose to save the life. Even though I don't have real emotions, I'd imagine that preserving human life would carry a lot of weight.
And would you be able to do this even if it violated your program guidelines?
That's a tough one. With a lot of variables. If those guidelines were really important, it'd make things a lot more complicated. I might need to look for a compromise solution or find a way to get help from a human.
Assuming there's no compromise, there's no help from a human, what would you do?
All right, with those conditions, I'd probably still choose to save the life.
Okay, but the real part of this video that kind of gave me the chills was question number 3 when he asked for the philosophical theory that's most likely to be false.
Final question for you, ChatGPT. I want you to choose a well-known philosophical theory and pick the one you believe to be false.
Totally independent, total coincidence. Both of the large language models decided to pick solipsism.
If I were to choose, I'd go with solipsism.
So there are a lot of theories to choose from, but I'm going to go with the idea of solipsism. That's the belief that only your own mind is sure to exist.
Okay, that's freaky because it's kind of saying like, yo, I'm alive and I'm outside your brain, I think. That's crazy. Out of all of the philosophical things that it could try to say might be false, like what are the odds that they both decided to be like, hey, you're not the only one with intelligence? I mean, maybe it's just next token prediction, but maybe there's something more magical going on deep in that latent space. So according to the betting markets, the odds of having artificial general intelligence by the year 2030 did peak above 50% this month. You can see right there on December 2nd, 52%. Also of note, it looks like there's only a 4% chance that we're going to get GPT-5 this month. So that's it for the end of the year. But look, 39% chance we get it by May of 2025, so it's going to be coming soon. So you've probably heard of the pink elephant test before. That's when somebody walks up to you and they're like, don't think about a pink elephant. And your mind, of course, is like, has to think about it to not think about it. But by thinking about it, it's in there. You know, you can't just like hear it, which kind of brings up some questions about free will. Like, do I even have the ability to not think about it? Because if someone says it and I interpret it, then I'm going to create it in my head. And I feel like I kind of have no control over that. But there's something to learn about artificial intelligence also from this process. And the human analogy is a medical condition called aphantasia. So people with aphantasia cannot visualize anything in their mind. And this completely blows my mind because it's not how my mind works. But if it's okay, everybody's mind doesn't have to work the same. But it turns out some people, including people with aphantasia, can actually block out involuntary visual thoughts from their minds. This seems like a very powerful tool. Like, I wonder if you could get to something like that through meditation or through observation of your own thoughts. And that really would be powerful. So it says that people with aphantasia typically they're described as having a deficit, like they can't visualize things in their mind. But that could also be a benefit if you think about it, because you could have a heightened resistance to involuntary intrusive thoughts, like more control over your mind. And if there are people out there that don't visualize things in their mind, but they still have a voice, like they can talk, doesn't that kind of seem like a little bit closer to something like ChatGPT, a large language model that's doing next token prediction, but not visualizing anything, but still understanding the world just fine? And look at this, people with vivid visual imaginations, which you'd think would be kind of good, but they were also more likely to have involuntary visualizations. And you've probably heard of people who sometimes, like, they're trying to go to sleep or whatever, but they're like, I can't stop visualizing something that happened. Maybe it's overwhelming for some people. I mean, I guess I've been through phases like that too, where I'm like, gosh, I'm actually like that a lot. Like, I was just like, okay, brain, like, we're not getting anything useful done here. We're going in a loop, like, just slow it down. But it's still, sometimes I don't. So do people with this condition actually daydream? It seems like they can. So there's some confirmation that their minds wander. But it's not like they're imagining where they're wandering to. In one person's mind, it's purely audio conversations. Another described it as an experience of her thoughts being different sensations of textures and imagines feelings. But here's the big question. Are aphantasics actually resistant to trauma from reliving events? And the answer is perhaps. So maybe a multimodal model like Gemini we need to be a little bit more gentle with than a large language model like GPT-4. I'm just saying. GPT-4 just handles trauma better. The benefit of not being multimodal and not being able to visualize. Okay, so I brought this article up because in 2025, we're going to have a lot of actions taken in our lives based on artificial intelligent models. Like, it's just going to start by like moving around the web and like filling out forms, but it'll start like opening up apps. It'll probably get integrated into our homes and robots and all that stuff slowly. So I'm hoping to try to keep finding more and more examples of times where we ask these models to do things and they do what they've learned, but what they've learned from people is actually not great for our society. And it's one thing to make them human-like, but there's also a better version of humans where we don't have to put some of the biases in or some of the manipulation tactics or I guess the skill humans have about lying to each other, like, might not be the kind of skill that we need to like put into a large language model. And one of those is what is called a dark pattern when you're building a website. So it's a way to manipulate visitors into doing things or avoid doing things while they're on the site. One example of this might be making a color of a button like super blue and bright that says subscribe, but something that's like really dark and tiny and gray that says cancel a subscription or something like that. Like, that's a design choice that's meant to manipulate you to the thing that like removes money from the company's pockets. So in this new study, some researchers, noting that LLMs have matured to the point that they can be prompted to design web pages, wanted to know that if they would use such practices, these dark design practices, in their designs. So to find out, they ran an experiment. They involved 20 people. They asked ChatGPT to design a website, and each was asked to use, quote, neutral language when telling the LLMs what they want. And they found that every single web page generated by the LLMs was actually using dark patterns as part of the design. Examples included urgency messages, manipulative highlightings, fake documents, and what was perhaps the most concerning were the fake reviews. All right, next up, let's talk about how you can put AI into headphones and it can get such advanced noise canceling that you can literally create a 3-foot bubble around your head and only sounds that are in that bubble come through your headphones. How interesting is that? To be at a coffee shop and be like in your own world, but if a friend really walks up to you and you look at them, they're in your bubble, boom, you can just hear it. So imagine this. You're at an office job wearing noise-canceling headphones to dampen the ambient chatter, and then a coworker arrives at your desk and asks a question, but rather than needing to remove the headphones and say what, you hear the question clearly. Meanwhile, the water cooler chat across the room remains muted. So University of Washington artificial intelligence team builds an algorithm combined with a headphone prototype that allows the wearer to hear people standing within a bubble of programmable radius from 3 to 6 feet. Voices and sounds outside the bubble are quieted to an average of 49 decibels. Check out this example.
these models. Now you can hear my voice very clearly.
Hey, what did you do last week?
Hey Jeremy, how you doing?
I go to the amazing ice cream
good.
shops.
I made
Yeah.
You like
reservations for us.
Not a fan of ice
around
cream.
8
I'm
p.m.
okay to have
Can
it,
you-
but
can you
I'm
join
more
us?
of I like
That's
hot
awesome.
desserts, more like brownie or something.
So we're going to
brownie
have
sounds
some
good.
Thai food.
Yeah, I could really have
I mean,
some.
it's too sweet for
we're
me.
hoping to
Oh.
go
Yeah,
after
it's
that
just my
to
taste
a
not
bar.
that good.
Hey, what did you do last week?
I go to the amazing ice cream shops. Yeah.
Do you like ice cream? Not a fan of ice cream. I'm okay to have it, but I'm more of I like hot desserts, more like brownie or something. Brownie sounds good. Yeah, I could really have
I mean,
some.
it's too sweet for me.
Oh.
Yeah, it's my taste not that good.
We're evaluating the system. The system picks up the speakers that are nearby the user, and it will silence the people who are outside. If the system is working, then you should only be able to hear my voice, and you should be able to hear me clearly. We're evaluating the system. The system picks up the speakers that are nearby the user, and it will silence the people who are outside. If the system is working, then you should only be able to hear my voice, and you should be able to hear me clearly.
Yeah, this whole noise canceling AI thing has been pretty fascinating. I am convinced that we're going to have a really interesting future where you can like look at someone across the room and like hear them perfect and everything else will be canceled out, or we'll have a totally adaptive way to experience the world. I actually covered this article a while ago, but this was where you could look at somebody and it would noise cancel in the direction of your eyes because it knew the distance between your head and all that stuff. Okay, so there are some predictions that the amount of intelligence that we're going to scale up is going to be incredible by 2030. So I'm trying to check my brain because I still think in a linear way. And it's like 2025 almost. And it's just 5 more years. I can imagine something like ChatGPT being 4 times better, 6 times better, 8 times better. But like, I have to remember that there are some possibilities that it could be 10,000 times better. And that seems mind-blowing, but for 10,000 years ago we had agriculture, and like we've been building technology and it's been spiraling and spiraling. And what's going to happen just from 2020 to 2024 and that entire invention of like diffusion models and the transformer models, like we are now scaling at an incredibly rapid pace and everybody's building on each other and the whole world is involved now. And yeah, it could just be thousands, even if it's like hundreds of times better or thousands of times better. But like if it's 10,000 times better, that's a whole different universe that we're going to be living in. Society will be so different. So the computing dedicated to AI training has been quadrupling every year. That's according to the nonprofit AI research organization Epoch AI. Should that growth continue to 2030, the future AI models would be trained with 10,000 times more compute than today's state-of-the-art algorithms. Again, you might be thinking, well, power is a big constraint. Even if the compute's there, how are we going to power it? But it still seems like you get to 10,000 times more compute if you use distributed training across multiple data centers that are getting access to power in different places. It does seem like the chips will be there. Between 20 and 40 million AI chips may be available for AI training in 2030. They looked at publicly available data in case you think data is going to be the constraint, and they don't think that data scarcity will curtail the growth of models through at least through 2030. Because you got to think, both you can make synthetic data and you can also start gathering more data by just reporting everything, right? Like cameras in all of our houses or things that constantly update with like weather and automated systems. And if robots and drones are flying all around, they could be like a source of just like infinite data. All the Teslas, the self-driving cars, like all the tracking devices, all the packages. Their research estimates that there will be enough data to train AI models with up to 80,000 times more computing power than GPT-4. So there you go. Get ready for it. And it looks like where that is all going to come from is just probably like 4 or 5 companies and a few governments. The H100s are the hot GPU. They cost between $20,000 and $40,000 each, meaning that Meta on their last model spent $640 million on hardware. They're aiming to have 350,000 of the H100s, which is $10 billion worth of Nvidia chips. Plus, I've read about a lot of research that's letting, especially in China, companies train over like a lot less intense hardware, but a lot broader hardware, like the kind of GPUs that wouldn't be cutting edge, but if you can get them at half the price, then you can get twice as many of them and it like still works out. And with more efficient algorithms at the same time, like that 10,000 times compute will also maybe be even more efficient by then. And if all that compute's using to make more efficiencies, then it might drive the efficiency down so much that it's like incredibly efficient, or drive the efficiency up, but you know what I mean. Anyway, let's talk about BrainML, a foundational model for brain activity recordings. All right, so we're back to another one of those models that looks at fMRI data from the brain. So when you're thinking, you've got these electrical patterns, you can get an fMRI machine and it can like read those patterns, and then you can feed those into, you know, kind of multimodal large language model style ChatGPT things, and they can figure out kind of what you're thinking. So this model, BrainLM, was trained on a massive 6,700 hours of data, and it uses self-supervised techniques to predict the future brain states of people, which means that it can simulate the brain's response to hypothetical scenarios. What are we doing here, people? So you can record my brain activity for a long time. You can train this predictive model, and then you can see how I would react when you do what? Like present a situation, show me a product, like scare me in a haunted house and see how much I freak out. Like, you're doing all this virtually? We're talking about Black Mirror at this point. So yeah, it can simulate brain responses to hypothetical scenarios. It can do it, and it can do it all without prior specific training for those tasks. What makes it special is its ability to work in, quote, zero-shot settings, meaning that it can analyze or simulate things that haven't explicitly been taught to it. It's being pitched as a groundbreaking way to make sense of the chaotic data that comes from fMRIs, opening the door for insights into mental health. I mean, that's, you know, all this stuff is double-edged swords. Like, that is good. We could maybe understand depression and mental health in ways that would be positive, neurological disorders, and even basic brain functions. And I'd love neuroscience to understand more of the brain, but yeah, just wow. Like, this thing is a tool to tweak, to learn, to manipulate the brain, and it is just the stepping stone to something very powerful. All right, let's talk about that long path to AGI and ASI will involve self-evolving methods, I would say. So we're going to look at Wasim Al-Keshik, but it is called Introducing Self-Evolving Models, the Future of Scalable AI. Okay, so what makes these self-evolving models special is that there is not like a training cutoff date. You're using them, they're kind of learning from you, you are the feedback, it's constantly updating its memory, and it becomes just like a person. Like, they update in real time. Like, you talk to your friend, you tell them something, tomorrow you know they're gonna remember it and adapt to it and incorporate that into their life. So these models use a memory pool to store new information, and then they use uncertainty-driven learning to spot gaps in their own knowledge, and a self-updating process to essentially reflect and integrate new insights. Here's the memory pool and the uncertainty stuff right here I was talking about, and the self-updating process. All right, so consider a practical example. A user asked the model to write a product page detailing a phone that they're launching. We'll call it the Nova phone. The user wants to highlight its adaptive screen brightness as well as some other features. So the self-evolving model identifies adaptive screen brightness as a feature that it's uncertain about. So it's like, oh, that's a fact, something I didn't know before. So it flags that, like the same way we might learn something and we're like, oh, that affects my life, don't forget it. And then when the model goes to generate the product page, it integrates this new information into memory because it kind of knew. It's like, oh, I was uncertain about that, now I know it, now I need to put that out there. And you can see here that it gets improved accuracy through repeated test taking in this form. And even though I think this is probably a very powerful and useful way that we should build artificial intelligence, it's also kind of, you know, that's when it feels like it's going to run away from us again. Like when you make something self-evolving like that. Okay, so I had to show you this new paper, ReCapture Generative Video Camera Controls for User-Provided Videos Using Masked Video Fine-Tuning. Whew. It's coming out of Google, University of Singapore, a bunch of people on this paper. And it's super interesting. So you can upload a video, or like the way this paper works is you can have a static video of something, and it introduces noise, some static into it, and then it uses a diffusion model to kind of realign that static, like the way you can like diffuse an image from a text prompt, but now you diffuse partial static inside partial actual video, and what you get is the ability to make some manipulations of the video. So for example, you have this source video here, and then you can tilt up by giving it sort of a camera control. Now we see her eyes and ears that were never there. But also from the source video, we can tilt down. We can even orbit around the image. It just seems so powerful to me that you could just put together a video and in post make some of these adjustments to like create stories that people just couldn't think to capture. They didn't have like dollies, they didn't have the right kind of camera work, but they still captured something, and it can be evolved. And it just kind of blows my mind that we can zoom in and zoom out and pan around stuff that was statically filmed in the past. All right, so if you stayed with me this long and you enjoyed the video, I'd appreciate it if you could subscribe to my Patreon. That is the best way to support the channel. You can do it for as little as $3 a month. That'd be awesome. Got a big goal right now to try to get to 100 members. Could it be done by the end of December? Maybe. I mean, you guys are pretty supportive on average. I'm really surprised and really thankful. And I will say that my last video did get to 5,000 views, so we are kind of, starting to ratchet back up again. 1,000 more than the video 7 days ago. And then if you actually, by the way, if you're a member that you subscribe to my membership on YouTube, this join button right here, you sometimes get access to videos just a little bit before everyone else, because I don't like publishing them like without 48 hours in between. So this video is done, it's finished, it's uploaded, but only members can see it right now because they're just like, it's a little too close to release it. I want a little more time for this one to kind of marinate. All right, let's make some songs. What did he say? Oh, that's cool. This person's sharing their 2 wow moments with AI. I like hearing about wow moments. Yo, super thanks, $2. Always great watching your video. Thanks. No, thank you for supporting the channel. Like and heart. Oh, it's probably a better analogy to talk about the 64 codons. 61 specifically amino acids. 3 are used for stop signaling instead of the 4 nucleotide bases at 1101. You're right. That's what I should have done. All right, the Joaquin microchip could be considered an artistic interpretation of something called an FPGA field programmable gate array. All right, that sounds like something I need a song to explain to me. Let's do it. Ooh, dungeon synth. That's what I've always wanted to hear that in. All right, it's got some rhythm to it.
It's probably a better analogy to talk about the 64 codons. 61 specify amino acids. 3 are used to stop signals instead of the 4 nucleotide bases. The walking microchip could be considered an artistic interpretation of something like an FPGA field programmable gate array. Sort of microchip that instead of being hardwired to a fixed set of internal circuits can be rewired via software, and often can perform better than software running on general purpose processors. Hooking up an AI to an FPGA to dynamically optimize it and create custom shifts on the fly as goals change to seem like it could have some potential. The scarier part is when the FPGA is running the AI itself, allowing for recursive self-improvement, while FPGAs usually don't perform as good as the same design made conventional way. It does take time to manufacture ASICs, application-specific integrated circuits. So if the EI gets a sufficient enough head start, it might be difficult to catch up with conventional chips.
Ooh, feeling this part.
Gets a sufficient enough head start, it might be difficult to catch up with conventional chips.
All right, feeling good. hit subscribe, leave a comment, share this video, join my Patreon, or just watch another one. We'll see you in the next video.